Okay, so now let's first talk about the Android thread model um, before making any further changes to our app's architecture. Um, so when an Android app starts, it basically starts the main thread, and that is the UI thread. So all the UI rendering, um, most of the interaction so far has happened on that thread. And this thread then dispatches events for the appropriate UI widgets. So the listeners that we have implemented, for example, they are observing things on a different UI thread, a different thread, not the UI thread, etc. So um, here is the basic rule for uh, handling UI threads. First of all, do not block the UI thread. That is, do not make calls to say something on the network through the UI thread. And the corollary is basically use the UI thread only for doing the UI related work. That is rendering widgets and so on, right? So basically drawing the UI and dispatching the events, not really waiting for an event, not really um, calling something that may take a long time, etc. So that's the basic idea here. Um, the UI thread is dedicated to just drawing the UI, and it's absolutely important that your app is responsive. If it is not, then that's not a good user experience. That may indicate some other flaws in your design, and it's generally not a popular app if it's not responsive. If you are as impatient as me when dealing with websites and applications and things like that, um, if the app does not show some indication that it has received my input, a spinner that tells me to wait is also fine at some level. But if it does not even show that, then that's not a good app. If I have to keep on clicking the button again and again, um, I'm probably not going to want to use that app a lot. So that's the main point with the UI thread and responsiveness. So all other operations, network access, database access, they should happen on a separate thread. Here is a concise best practices for UI thread. Complete all the work in less than 16 milliseconds for each UI screen. Now, you're not going to, of course, count for 16 milliseconds, but that is the current threshold for displaying the ANR, the dreaded ANR, application not responding, which is what you get um, if your application, well, is not responding. And you might have seen this dialogue like, the application is not responding. Do you want to wait or kill? Right? So that you don't want your app to go there. You don't want your users to ever see that on your app. Um, that happens when it does not respond to some critical things, say like pressing a back button, or the UI has not updated for 16 milliseconds, um, or things have not changed essentially for a given threshold of time like that, even after a user has interacted with it or tried to interact with it. Okay. So again, what that basically means is don't run long-running tasks like background, the things that may take a lot on the background. That includes again network access, database access, things like that. Um, and don't have any background thread manipulate your UI. Don't try to do that. Don't cleverly pass on like widget references to one of the background threads and update it from there. So both of these are a clear no-no, right? Okay, so what you can do then to access the database on a different thread. Um, so you can use something called an async task, which gets a little complicated, and Android is deprecating some of its methods recently. For our purposes, currently, an executor should work perfectly fine. So executor comes from Java util concurrent, and it basically references and accesses a thread Executor has an execute method which accepts a block of code which will be executed, as the name suggests, on the appropriate thread this instance of executor was created with. We'll see an example in a second if it's getting too vague at this point. Um, but now here is the thing. Where do you implement this, right? Where do you create a thread? um, you cannot create a thread in the hang on, so we need a thread, we need a separate thread to access the database, because database is on the device, it may be on the network, we don't know, and it may take a lot of time to access the database, right? So it should be done um, as soon as possible after the database part of the layer. So which Java class actually accesses the database? It's the DAO. But can you create a thread in the DAO? The answer is no, because, well, you never implemented it. It's the room library that implemented it. And I mean, to be frank, it takes care of some threading, but it doesn't know about all your queries and how to handle those. So what is the next layer after that? It is the repository. So you can do this, you can create a thread in the repository, and we are going to see how. All right, so this is the journal repository we created. All the code we have seen here is abstracted into these ellipses right now. And now we are going to add um, this code for get entries. Okay, remember we need to expose the methods for the upper layer. So get entries is a method that is going to call get all entries is a method that's going to call get all entries on the DAO, and it will then return a list of journal entries, and not really, it will return a live data of list of journal entries, right? So this live data here takes care of your background thread issue. You don't have to do anything else. So this is the part which the room library itself implements for you. And you don't even see how it's creating the thread, and you don't care about it. So getting the list of entries as live data ensures that it will be executed on the background. So most of your get queries will be fine. You basically put its real return value, return type into a live data, and that's it. You're good. But um, what about the insert query, right? Insert query did not have a live data as a return type; it was void. Um, so how do you handle that? So for that, you can create an executor like this. Okay, so the executor is created using a new single thread executor. And this is the instance that we'll use to run the database queries. And the new single thread executor basically ensures that the code will be run on a single new thread every time. And then this is how you can write the insert method in the repository. So insert takes an entry, the journal entry, and um, call executor.execute, and you pass it a function. So this is part of the functional programming aspect of Java, added in Java 8 onwards. Um, Basically, it simplifies writing code for us, and you can pass a block of code itself instead of creating an object and then implementing an anonymous inner class and so on. So I'll not go into the details of that, but we can discuss it outside of this particular video or this particular lecture. So what's happening here? You're calling journal entry DAO.insert and passing it an entry. If you go back to the DAO class, this is the method you have in there. Um, and that's what you want to execute, but on a new single thread. Okay. So once again, insert did not have live data as a return type, etc. So we need to execute the insert method on a background thread, and we need to create a background thread like this. So, and this is the functional programming aspect. Okay. So now we are done with our repository. In this repository, we have methods that will access the underlying room database, um, and it exposes the methods like get all entries and insert for the upper layer, that is the view model. And if we ever change the database from a local room database to something else, um, I mean, if we change it to say something on the cloud or another web server, we just need to plug it in the repository, and the view model and upper layers will never know about it and will never care about it. Okay, now we are at the view model. So we know what a view model does. Uh, Before we started looking at the room library, it's supposed to provide the data for the UI, and it's designed to survive the configuration changes. So it will continue to do that, and to do that in this context with the database library underneath, what it will do is it will basically expose APIs for the UI layer. Um, uh, it will it will be the bridge between the main activity, in this case, that is the UI layer, and the repository. So it will hold a reference of the repository and it will call methods on that. Due to this live data here, it will also implement an observer pattern later in the main activity, which will um, get the changes from the view model. Okay, so let's take a look at the view model. So general view model, extends view model, all that is very standard by now. And in the constructor, we are getting the instance of the repository. Remember, it was created using the application context in the application lifecycle on create method. And well, I mean, then it's just a simple wrapper or a bridge for the methods on the repository. Okay. Get all entries calls mRepository get all entries and returns whatever it returns. Insert simply calls the repository's insert method, which we just saw uses an executor to create a new thread underneath. Okay, yeah. So this is from the singleton, and now, finally, we are at the UI and controller layer of this architecture. And the important thing here is the recycler view. So, recycler view is used for displaying um, a large list, um, which can be dynamic. Things can be added anywhere in it, in the middle of it, at the end of it, any place, and it should be scrollable, and it should display the appropriate items from the list at the given time without any delays on the UI and so on, of course. Okay? So recycler view is the component that you'll use to do just that, okay, to implement that. Um, okay, so we'll take a detour here and talk about what a recycler view is or does, and then we'll come to implementing the actual code. Yes, so recycler view has it's several sort of underlying layers, and the key idea is um, all the items that you would show on the recycler view are similar. Like the list of messages in your WhatsApp or any other messaging app, um, a list of say recipes on your on your recipes app, for example, or um, if you even I mean if you have a in the clock app, for example, if you have a bunch of world clock times, New York, London, Delhi, etc., um, then all of those are similar, but they are different. They have different data, but they have the same structure. So the idea is, instead of creating a new view item for each list item, um, use the recycler view, which, as the name suggests, recycles the view and renders it for all these different items, which it gets from the database or some underlying actual Java concrete list. Okay. Um, it caches the created view items and efficiently displays them at the appropriate time based on their position in the list, and it reuses them with different data as the user scrolls through the list. So it doesn't then create new view items, it just reuses them. It modifies their what the components inside them, say a text box or another widget or a symbol or an icon, all of that. It reuses what they should be displaying based on the data it gets. So that is the idea. Um, we will see a recycler view here at the bottom, as you can see, and it handles a layout manager. And in our case, it is going to deal with a journal entry item. Now, um, here is the data at the top in this picture, which is an item journal entry. And then we need to access that in the UI controller. And to connect these two, we have an adapter, uh, journal view list adapter in our case, and it has a view holder inside, which this adapter, as the name suggests, basically is going to act as the bridge between these two things, the data, which is a different type, and the UI controller, which is a different type. And both of these are pluggable through the adapter. Adapter makes them work with each other. Okay. All right. So let's quickly look at the main activity UI and include a recycler view on the UI, so we can go and start writing the code or make those changes. So um, yeah, here is a component tree. I'm going to make the code of this activity XML available, but this is the structure. There is a constraint layout parent, and then it has a recycler view. So everything here inside it is a recycler view, and this is a floating action button. You can drag and drop recycler view as well as floating action button from the palette in the UI editor, layout editor. This floating action button is it works like a button, but it can be floating, as in um, it's not taking any real estate on the layer that is the recycler view underneath. So you can have this button on the left bottom corner, top right corner, anywhere, and that doesn't really affect what's under it. You must have seen such buttons in, say, email apps or things like that. I think the Gmail standard app has a compose button like this. Um, anyway, so this button, is clickable, and it can have an on-click method like this. We'll call it launch add entry activity, because this should take you to the other activity where you actually enter um, the journal entry details. Um, I'm not going to show what happens in that activity. It's pretty standard for us by now. Um, so, I mean, not going to show the code of this. You're going to create an intent, um, launch the activity, and in that activity, you will get the string title and in duration from the user. You have seen the UI in one of the previous slides, and then send it back using another intent for result, and then create an entity in the main activity. That's what you'll do. That code is pretty standard by now. So yeah. Okay, so here is some code that uses the recycler view and connects with the adapter. Let me actually pause here. We'll do that in the next video. Thank you.